Hello students, one more problem for IIT advanced level which I got for you today. Problem ये है कि पहले मैं problem को पढ़ता हूँ and try to understand the problem and later I will try to solve it there on the other side of the board here. Problem ये है कि the figure shows a U-shaped rail track on which is a sliding wire. A uniform magnetic field is perpendicular to the plane of the U-shaped circuit of resistance R. The slider of length L is given initial push with a velocity V0. Find the velocity of the slider as a function of time. ये U-shaped circuit है and it has a resistance R here and it is a slider. ये बेसिकली हॉरिजॉन्टल सर्किट है, मतलब यू शेप्ड हॉरिजॉन्टल सर्किट है जिस पर सर्किट ऐसे कुछ यू शेप्ड है और इस पर स्लाइडर है, और लेकिन हमने इसको वर्टिकल प्लेन में बना दिया। और वर्टिकल प्लेन में भी ठीक है इफ यू नेग्लेक्ट ग्रेविटी। ऐसा नहीं कि आप इसको ऐसे समझो और आप ये सोचोगे कि ये स्लाइडर नीचे क्यों नहीं गिरता है। नेग्लेक्ट ग्रेविटी, this will not fall down. It will go in the forward direction, but it will not fall down. For that, you have to neglect gravity. You have to assume that there is no gravity. Otherwise, you have to consider the horizontal plane, the circuit in the horizontal plane. वो भी आप कंसिडर कर सकते हो या ऐसे भी सोच सकते हो, और फिलहाल आप ये देखो कि ग्रेविटी नहीं है, अदरवाइज आप सोचोगे कि ये स्लाइडर नीचे गिरेगा। ओके, नाउ द मैग्नेटिक फील्ड इज परपेंडिकुलर टू द प्लेन। आई मीन द मैग्नेटिक फील्ड इज इनवर्ड्स एंड इज परपेंडिकुलर टू दिस प्लेन ऑफ दिस सर्किट। व्हाट यू डू इज दैट, आप इस स्लाइडर को थोड़ा आगे पुश करते हो, वेलोसिटी v0। जब आप इसको थोड़ा पुश करोगे, ये जो प्रॉब्लम है इट इन्वॉल्व सो मेनी कॉन्सेप्ट्स। इट इन्वॉल्व द कॉन्सेप्ट, जब आप स्लाइडर आगे ले जाओगे, पुश करोगे विद वेलोसिटी v0, तो ये इस सर्किट में, इस रेक्टेंगुलर शेप्ड सर्किट में फ्लक्स चेंज हो जाएगा। जब फ्लक्स चेंज होगा तो देन देयर इज इंड्यूस्ड ईएमएफ। व्हेन देयर इज इंड्यूस्ड ईएमएफ इन दिस वायर स्लाइडर, तो उस इंड्यूस्ड ईएमएफ की वजह से क्या होगा, देयर विल बी करंट इन द सर्किट। और जब करंट सर्किट में होगा, दैट करंट फ्लोज थ्रू द स्लाइडर इटसेल्फ। जब वो करंट स्लाइडर के थ्रू पास करेगा, तो स्लाइडर तो पहले ही मैग्नेटिक फील्ड में है, तो इट विल बी अ कंडक्टर इन द मैग्नेटिक फील्ड कैरिंग करंट, तो इस पर फोर्स होगा। सो मेनी कॉन्सेप्ट्स आर इन्वॉल्व। Push the slider forward a little with the velocity v0, it will change the flux through this part of the circuit. When the flux changes, there is induced EMF in the slider. That induced EMF will send the current through the resistance, and that current passes through the slider itself. That means slider is now where? It is in the magnetic field. The slider carries current and is in the magnetic field. When this is in the magnetic field, there will be a backward force because it is a current carrying conductor in the magnetic field. As you know, when a current carrying conductor is placed in the magnetic field, there is force on the conductor, and that force, वो हम डायरेक्शन देखेंगे, वो फोर्स किस ओर होगा। That is all. तो पहला काम जो हम करेंगे सोल्यूशन में, स्टेप 1 में, वो ये है कि how much is the induced EMF when I push this slider in the forward direction? वो आपको शायद याद होगा, induced EMF, अगर नहीं तो वो निकाला जा सकता है। induced EMF E is equal to V velocity, B magnetic field, constant magnetic field, into L length of the slider. It can be found very easily. तो अगर आप चाहो तो वो निकाला जा सकता है, लेकिन यही आंसर तो यही आएगा। द इंड्यूस्ड ईएमएफ इन द स्लाइडर इज VBL. Okay, I will try to find it in a moment for you. Just here, I will try to find it out. अगर इसको आप x समझो, तो बताइए फ्लक्स क्या है? What's flux? Magnetic flux. That is B magnetic field into area, that is Lx. This is the flux, because magnetic field is perpendicular. and the flux is simply magnetic field into this area. That by definition. So if you differentiate this, that is d phi b by dt is equal to bl, वो कांस्टेंट है दोनों, और x का डिफरेंशिएशन होगा जब ये स्लाइडर आगे जाएगा तो दिस x विल चेंज. तो इस x का डिफरेंशिएशन यही है कि इस स्लाइडर का आगे वेलोसिटी क्या होगा. तो इट इज dx by dt, that is bl and v. Answer. It will not be bl v0 because we are finding induced EMF at any time. It is the initial moment the velocity is v0, but at any moment velocity is not v0, velocity is anything. Okay, now this is induced EMF which is generated in this slider, and now this will produce current through this resistance. So what is the current? The current is induced current, that is induced EMF by resistance, that is VBL by R. ये करंट, इस करंट का डायरेक्शन क्या है? तो अगर ये स्लाइडर आगे पुश हो रहा है तो इस स्लाइडर की वजह से ये फ्लक्स यहाँ इंक्रीज होगा इनवर्ड्स. व्हेन द फ्लक्स इनवर्ड्स इंक्रीजेस, द करंट इंड्यूस्ड इन दिस सर्किट विल बी सच एज टू रिड्यूस दैट फ्लक्स. सो करंट विल बी लाइक दिस, and this current is such as to produce the magnetic field outwards. So the current is produced in such a way as to oppose the increase in the flux inside. So that is why the current is in this direction, produced by the induced EMF, so that it opposes the change in flux inside. So current has this direction. Now this is a current flowing. The slider, inside the slider there is a current flowing in the upward direction. So it's a current carrying conductor in the magnetic field. When there's a current carrying conductor in the magnetic field like this, it is the slider here, current is upwards, magnetic field is inwards, I cross B, that is this way. This way is the magnetic field force. This is the magnetic force. That is it. तो ये आप ऐसे भी याद रख सकते हैं, जब आप स्लाइडर को आगे की ओर पुश करोगे, समझ लो कि मैग्नेटिक फोर्स अपोज करेगा उस पुश को. Magnetic force will like that the slider should not move in the forward direction, because moving the slider in the forward direction will change the flux. The change in flux will produce the current, and current is such as to oppose the change in flux. That is why the force created will oppose that change in flux. It will try to pull the slider back. या ऐसे भी सोच सकते हो, अगर करंट ऊपर की ओर है like this, magnetic field is inwards, so I cross B is this towards a dragging force. So it is a dragging force. Now the question is, how much is the dragging force? Step number 2 is force on a conductor, F, which is backward magnetic force, that is I L cross B. That is the formula that we know, the law. That is F is equal to I L B. Because L, length of the conductor, and magnetic field, which is inverse, they are perpendicular to each other. That's why it is LB sin theta. Theta is 90, is LB. This is the conductor like this. L, length of the conductor has upward direction, and magnetic field is inwards. The angle between the two is 90. Therefore, it is LB sin 90. That is LB. This is the magnetic force, which is opposing the motion. Now, ऑब्वियसली ये जो वेलोसिटी है, जो आपने इनिशियल वेलोसिटी दिया, अब ये वेलोसिटी आगे जाकर के कम होता जाएगा. इट विल डिक्रीज बिकॉज देयर इज अ ड्रैगिंग फोर्स. देयर इज अ ड्रैगिंग फोर्स इन द बैकवर्ड डायरेक्शन, एंड द स्लाइडर इज मूविंग इन द फॉरवर्ड डायरेक्शन. और आपने पहले स्लाइडर को v0 का वेलोसिटी दिया है, लेकिन अब आपको खुद ही फिजिक्स के थ्रू सोचना पड़ेगा कि आगे जाकर ये जो स्लाइडर है इसका वेलोसिटी कम होता जाएगा. एंड फाइनली आफ्टर सम टाइम दैट वी डोंट नो अनलेस वी डिराइव इट, तो आखिर में ये स्टॉप हो जाएगा. But okay, that will be a question after how much time it is going to stop. So that is the force. So what is the equation? Step number 3 अगर मैं कर दूं, what equation that I am going to write for this? कौन सा equation लिखा जा सकता है इस force के लिए? Third step is Newton's law. What is that? F is equal to ma. What is force on this slider? That is this force. That is minus I L B. Negative because it is opposite to the motion. Is equal to mass into acceleration is A. Now, what is this acceleration? That is minus I L B divided by M. Substitute for this current. When I substitute for the current, so what should I write? So A should you write for A is dV by dt is equal to, what should I write for I? VBL. So if I put I VBL, it will be V L square B square, because LB is here also, और वो LB multiply करके ये L square B square होगा by M. Now what is dV? dV, separation of variables. Here's a concept of separation of variables, means ये जो V वाले चीजें हैं या V वाले जो variables हैं वो एक साइड लो और बाकी टाइम वाला variable दूसरे साइड लेना पड़ेगा. So it is dV by V is equal to minus L square B square by M, और ये dt यहां पर लिखेंगे, right? Okay. Now I will integrate both sides. Integrating both sides. Integrating both sides. Integrating both sides. It is dV by V. इंटीग्रेट कर कीजिए आप, इज इक्वल टू माइनस L स्क्वायर B स्क्वायर बाय M इंटीग्रेशन dt. या मैंने कांस्टेंट पहले ही बाहर निकाला है, जो दूसरे स्टेप में बाहर निकालना पड़ता है वो मैंने पहले ही बाहर निकाल कर रखा. सो व्हाट आर द लिमिट्स ऑफ इंटीग्रेशन? इंटीग्रेशन की लिमिट्स क्या देंगे आप? पहला वेलोसिटी क्या था, इनिशियल जो पुश आपने दिया है, दैट इज v0, और व्हाट विल बी द वेलोसिटी आफ्टर सम टाइम, not final, after some time, let that be v. What was the initial time, starting time? That's always taken to be 0. And what is any time? Let me say that is t. It is velocity v at any time t. It is v0 velocity at time t is equal to 0. This is how we give the limits to the integration, how we define the initial conditions, or you sometimes what you call is the boundary conditions. Means initial velocity and velocity at any time, initial time and any time. Okay, so what is the integration of this? That is ln of v under limits v0 v, ये वाला is equal to minus L square B square by M. ये कट होकर के सिर्फ यहाँ t रहेगा under limits 0 to t. तो it will be ln of v minus ln v0 by substituting definite integral, substituting this, is equal to minus L square B square by M t minus 0. So it will be ln of v by v0, log rule, log m minus log n, log m by n. That is what you know. As an IIT student, you are supposed to know those basic rules of mathematics. It will be minus L square B square by M and T. Okay? We are closing up. We are very, very near to the final equation. So, it will be like this. Have a look. It will be v by v0 going to the anti-log onto the right side. That will be e raised to power minus L square B square by mt. Now v, velocity at any time, is equal to velocity at time t is equal to 0, initial velocity, e raised to power minus L square B square by mt. This is the answer for the question. That simply means if you give the initial push with the velocity v0, velocity will decrease exponentially. That means its velocity will become 0 after a long period of time, at infinite time. At t is equal to 0, if you put t is equal to 0 here, v is equal to v0. But after infinite time, after a long period of time, the slider will stop. So exponential means that it will take a longer period of time before it stops. This is an IIT level question, most likely to be asked this year, because it involves so many concepts in a single question. And if you do this question many a times, so many things about electrodynamics will be clear. इस क्वेश्चन में बहुत सारे कॉन्सेप्ट हमने डिस्कस किए, कैसे स्लाइडर को आगे जाने से, आगे मूव करने से कैसे फ्लक्स चेंज होगा, फ्लक्स चेंज होने से कैसे इंड्यूस्ड ईएमएफ प्रोड्यूस होगा, इंड्यूस्ड ईएमएफ प्रोड्यूस होने से कैसे करंट फ्लो होगा, और वो करंट स्लाइडर के थ्रू पास हो रहा है, उस करंट की वजह से ड्रैग फोर्स होगा, उस ड्रैग फोर्स की वजह से ये वेलोसिटी आगे आगे जाकर के कम होकर के फाइनली ये वेलोसिटी जीरो हो जाएगा. एंड I will continuously upload these lectures for IIT students, and students will certainly be benefited. And if you like the lecture, you can subscribe to the channel, and you can ask other students also to subscribe to the channel, because these are very important lectures through which you can be benefited. Thank you.